sine, cos, and tan of 30, 45, and 60 degrees angles. Now, we will refer to the special right triangles. There are two. The first one is where you have 45, 45, 90 degrees angles. And we recall the dimensions. The legs are equal, so we can take each of them to be 1, and then the hypotenuse to be square root 2. So that's our first special right triangle. And the second one had 30, 60, 90 degrees angles. So it's not isosceles anymore. One angle is small, so this small angle is 30 degrees. Another acute angle is large, 60 degrees. And then we said that this is, or you can see it, that this actually happens to be half of an equilateral triangle. If you reflect this and join this to that, you can see that it's half of an equilateral triangle. So if the hypotenuse is 2, then the short leg is 1 and the long leg is root 3. Now we look back at our definitions, and a lot of students use this mnemonic, at least for some time, SOHCAHTOA. So if I want sine of, say, 30 degrees, then sine 30 degrees is opposite, which is 1. So the opposite of 30 is 1, and divided by hypotenuse. So sine is opposite over hypotenuse. So sine 30 degrees is half. Now, if I want tan 45 degrees, then I look at this picture and get tan 45. So I can use either this or that. But in either case, I get the same answer. So if I use this 45, it's opposite over adjacent. Tan is opposite over adjacent. It's 1 over 1, which happens to be just 1. Now, if I want, say, cosine of 60 degrees, then I look at cosine is adjacent over hypotenuse. And 60 degrees exists in this second special right triangle. So adjacent to 60 is this 1 divided by hypotenuse is 2. So in this way, we can get sine, cosine, and tan for these three angles, 30, 45, and 60. Now, there are ways to figure out the trig functions for all the angles using unit circle, but these three are really special, and every student would be expected to know, and you would use them in problems. So just want to let you know, remember the special right triangles, and then you can get those trig functions quite simply. But we will look at an expanded definition of trig functions using unit circle in another video. Until then, I'll see you. Have good luck, and I'll see you next time. Thank you. Bye-bye.